Welcome to this live webcast on Start Bidding Faster. See how planning and using the right tools can help you get ahead of competition and start bidding faster and more accurately while utilizing fewer resources. My name is Sean Mulheron, and I've been with EPLAN since 1993 as the company was still called Viches and Partner. And since 2000, I've been in North America working for EPLAN. And since 2013, I've been part of the product management team. And now I'm responsible for EPLAN pre-planning, EPLAN Electric P8, and EPLAN Fluid. So today's webcast is going to give you an idea on how to better handle bidding processes and calculating quotes in regards to controls design projects. If we look at today's approach, a customer will typically use a Word document, an Excel file, maybe some Visio drawings or some other kind of drafted graphical elements. And he'll try to combine this information also with his experience and assign prices and times and scheduling to various different items on that particular project and try and collect that information and summarize it to get a total quote. This is mainly working because the person doing the quote has done a quote multiple different times and is very experienced in the art of putting systems together and understanding what does it take to put them together. The challenge, however, is if the experienced person is not there, figuring out how can we calculate the time needed to design a system, put systems together, attach prices to it, and store that information in libraries where we can reuse that information so the next quote can be accurate and with the same amount of information without always having to reinvent the wheel. And there are not really any tools today out there to be able to help a user do that. And this is why the approach that we want to showcase today is using our tool EPLAN Pre-Planning as a planning tool to help users capture controls information early on in the design process, right away, right up close when a operator might be planning a system or asking for some bidding, and easily capture graphical objects, easily capture control systems, easily assign quoting data and reporting that data to actually generate or quote or information for a specific quote. So on that note, we'll jump over to EPLAN and then we'll kind of walk through the process and get you a better understanding of how that can work in EPLAN. Here, I've opened up the EPLAN platform, the EPLAN software, and on the left-hand side, you can see I have two pages open, one blank page. I have here my pre-planning tree, which is a logical view on specific objects. So without designing any kind of graphical elements, the first thing we can do is even create a logical tree structure. So we have a structure element, we've got a planning object, so I'm going to use my structure element to define a plant. This plant will have a name, for example, P1. I can add some descriptions if I need to. In my plant P1, I'm going to create a new structure element. It's going to be a set of buildings. So it's going to be building 1. And in this building 1, I will add another structure, which will be area 1, for example. You can easily modify the properties after they've been used if needed. And in this area 1, I'm going to also have a new structure, not for this one, sorry, in the building 1, I'm going to have an area 2. And if you want to, you can even copy and paste an area 3 in there, and the system can automatically help you create a structure very easily. So this is a way to organize the data that you need to create your controls design project. In area 1, I'd like to define a motor system. I need a motor control system, so I need to define that and capture the information associated with it. So in this case, I'm going to create a new planning object. A planning object can really be anything. It can be an actuator, it could be a converter, it could be a machine, it could be a pickup, or you can customize whatever you want. It could be an enclosure, it could be a valve manifold, it could be a conveyor system, it could be a robot, really absolutely whatever you want it to be. You can organize it however you need it to be. So in this case, I'm just going to take a motor, and this motor, I'm going to give it a name, for example, DRV1, drive 1. And this is going to be specific for my conveyor number 1. In this planning object, we see these different attributes. One is expenditure construction, expenditure planning, expenditure software. What do these mean? These are to capture times. For example, how long is it going to take to assemble and build that motor onto my system? How long is it going to take to plan that particular motor? And how long is it going to take to program it? And finally, calculation value is how much is it going to cost? So let's say for this motor, I'm not going to consider just the motor. I'm going to consider the motor plus the cables, plus the terminals, plus the variable frequency drive, and the protection devices all together. And putting that together is probably going to be at least an 8-hour process. So I'm just going to say 8 hours here. For planning the motor, it's probably going to be 2 hours. You have to size it and figure out how long the cables are going to be. And then to program it is probably going to be an hour to identify the function block and put it in the system. And calculation value, those types of motors with the drive, with everything, it runs at about $8,500, and I can capture a value. Now that I've done this, I can use that drive, and for example, I need one for my area 2, my area 3, so I can easily copy this. I can paste it, and I can paste it in my different areas. And as you can see, I haven't done a single page of drawing. All I've done is captured some control elements for my control system. And right there and then, without any further information, I can generate already a preliminary quote. So I'm going to go to Utilities, use my reporting techniques to generate a report, which would be which is a pre-planning object overview. I'm just going to generate this report, and I'm going to put it on page 3. That's it. There's my report, and let's take a look at it. And now what's happened is these 3 objects that I created have been summarized in a report, which is my planning object overview. It could be my quote. I've got my 3 conveyors, I got my planning time, I got my construction time, and I've got a summarized value here at the end for total value of my system. So this already gives me a really good idea in regards to the quote that I want to put together. And if you want to add another 10% on top of that, then that could be your final number if you wanted to. Additionally to that, each one of these drives can also carry I/O information. So I'm going to select all these drives since they're very similar. I can add, for example, PLC I/O. I need an output to start the motor, so it's going to be an digital output. I'm going to start it with contactors, for example. Then I'm going to add 2 more inputs or 3 more inputs for motor start, motor stop, and motor fault. So I can add, if I want to, I can add also a text, motor start, motor stop, and motor fault. And here I could just have this motor run, for example. So these would be the function text associated to these elements. Now, if I ran my report again, I'm going to update this report. And now look at that. It added all of the signals needed for each one of these objects, giving me a total number of signals. So right then and there, I don't have a drawing yet. I just have an understanding of the control systems that I'll need. I also have a number of IOs or signals needed for that particular system. So there I can already start sizing my PLC system and maybe go to the various different PLC vendors and asking them what type of PLC could support that type of system. So there you can see that pre-planning can be very useful in structuring information, but also capturing certain types of information or data associated to the bidding process, allowing you to bid faster by collecting the information faster and making sure that you've defined it faster. And again, if I had a second building, I could simply copy and paste it, put building number 2. Another benefit is we have what we call templates, pre-planning templates. These pre-planning templates, they can allow you to store a particular drive, like this drive configuration. I could store it in my library of templates. So then when I decide to create a new project, let's say I don't have any conveyors, I'm going to delete these here. And I want to start defining my conveyors, I can go to my library with all of my templates in there, and I can simply drag an actuator in here for A1, take an actuator, put it in A2, take an actuator, put it in A3, and same is true here. I can just run a report, and there you go. You have your quote already done. So using templates with all of the data already pre-stored can be very useful to quickly and easily put a quote together and generate the information needed for bidding. That is using pre-planning for its structure, for its objects, without doing any design. Let's take a look at a design approach. So again, I'm going to delete all of this. And I'm going to remove this particular page. And now let's say I need to design a conveyor system for a manufacturing facility. I'm going to start with a conveyor, so I can use a conveyor macro. So now what we're using is we're using graphical objects. This macro contains the conveyor, contains a motor, contains 2 light barriers, and a cylinder. By using my tab key, I've got 4 different variations, vertical and horizontal at different positions. So I'm going to place one system right here. I'm going to place another system right there. And you can see as I place these graphical systems, the system logically captures again the information associated with them. So in this conveyor system here, you've got a cylinder, you've got 2 sensors, and you've got your motor. And if I look closer to these objects, you can see that the information behind them carries all the information needed for quoting, how much time it's needed to build, to plan, to program, and what it's going to cost. Now I'm going to add a couple of more devices, such as a turntable. I'm going to place my turntable right here. I'm going to add a couple of robots. So I've got a robot system here. Using the tab key, I can orient the robot however I need to. I'm going to put one here. I'm going to put one here. And using my tab key, I'm going to put an oriented robot right here and another one down there. So now what's happening is you're doing a graphical pre-planning. A graphical pre-planning means you're using graphical objects, not just graphical objects, intelligent graphical objects that carry a lot of data with them. And this data can be data regarding bidding or quoting aspects, but also information regarding the PLC layout. So if I just took this system and I decided to go to my pre-planning report, and I would update that report with the new information, now you could see the entire quote or the bid for that particular system. You'd have your cylinders, your light barriers, your conveyors, your robots, and everything is added up to a total sum here at the bottom. And you can see here $84,000 for that system with a couple of robots associated with them. So this is just to give you an idea how pre-planning using intelligent graphical objects can really help you leverage speed and accuracy in quoting specific control systems. Now, the huge benefit is not only it helps you to quote it, but in addition to that, if I look beyond the robot system as an object here in my overview, I can see I have macros associated with it. And these macros can show me what the circuit diagram would look like for a schematic implementation. So not only I have the object for quoting and bidding, but also once I've won the bid, because I'm so accurate and efficient at it, I can also straight away use the information to drive my detail engineering all the way to the panel build and panel manufacturing aspect. So you can add as many different types of blocks. Like, for example, I've got a motor here. If I need to add an additional motor on that particular segment, I can just pop it right here and assign that motor to my second conveyor, for example. Just take it there and hit OK. If I had to choose the size of the motor, I could size it right here. And again, that motor could come with a lot of pre-planning information. I can also select a cylinder. Here's a pneumatic cylinder, and this pneumatic cylinder could also be positioned where I need it graphically, and it also logically is added to the tree or to my structure. I could have some sensors, for example, I need some proximity sensors, and I could just simply drop them here and here, wherever I need them for my particular application. Yeah. So a graphical pre-planning is not much different than what you might be used to today using CAD applications. However, there's a huge difference because the CAD blocks or the graphical blocks, as you understand them, now carry a lot of data with them. And not just bidding data, also graphical data, also logical data, PLC data, and wiring data associated to them. So a lot of information is now tied to these objects and can help you generate quotes a lot more faster, a lot more accurate. And on top of that, by doing that, not only you have a quote, but also you've got an initial view on what the system could look like. So conversations with your customer can be at a complete different level where he can visually see what you mean by the quote that you just provided, making the whole process a lot easier. So this kind of summarizes the approach of how pre-planning, the EPLAN solution pre-planning could be used to help companies or engineering generate quotes or capture quoting information a lot more accurately and a lot more efficiently. And again, by the fact that you store these objects in templates, that helps you to remove the experienced aspect where you have to have that person that's done it multiple times and knows exactly the ins and outs to be able to quote the system. The ins and outs of that person are stored in that particular block in the actuator, and all of the information is there, so the user can just drag that information onto the drawing and just leverage that data and just use it from there on forward, knowing that based on the library it's accurate. On this note, I would like to now open the session to questions. So there is a Q&A panel. If you want to open that Q&A panel and you can start asking questions. I'm going to look at the Q&A panel and see if we have any questions in there. So if I want to explain to my boss what EPLAN can do, what is the best way to do that? I like the more pragmatic approach of keeping things simple. And if you if you use CAD today, let's say you use AutoCAD, the approach to that is that, yes, you can do the same work, the result is the same, the difference is the time that it takes to get there. So if you have a project that you need, for example, 3-4 weeks to design, with EPLAN, it would literally take less than a week. So the amount of time that it takes to design is really your huge benefactor there, where it's your ROI. Of course, it will take a bit of time to set up and to get to add the blocks that you need and to set up the environment correctly, but you don't have to do it all at once. You can go project by project. So let's say you have one project coming in, you attack that project with EPLAN, you develop the blocks that you need for that particular project. Now you look at the next project, and suddenly a quarter of those blocks, if not half of those blocks, are already available, and you don't have to redevelop them. You can just use them and leverage that benefit suddenly. So it's an incremental process to gain the absolute ROI, but there's no doubt in my mind that the way that people traditionally approach an engineering project today from a graphical perspective is not the way to do it in the future, especially if people want to stay competitive and not spend so much time in the engineering process. So if you use other tools like maybe AutoCAD Electrical or even SolidWorks Electrical, the challenge there is, again, is the bottleneck is the underlying tool. These are two mechanical systems that are used as a starting point to do electrical. If you look at AutoCAD Electrical, for example, you will see that it's AutoCAD with a whole bunch of scripts and add-ons on top of it, which make the whole system AutoCAD very fragile in the sense of, what if I add a block which is not AutoCAD Electrical in there, and then you can break the system. So there's a certain amount of fragility in there, and you have to be very meticulous and structured to be able to stay there. EPLAN is not that at all. EPLAN is really just a database where you just start capturing your data, and if ever you made one mistake, you fix it in one spot and update everything else. So it's very streamlined in the approach to controls design. And as I said, if you want to save time in controls design, really EPLAN is the way to move forward with it. Oh, simply what other software packages EPLAN in a sense combines into one platform. So pre-planning is one where you have a specific structured tree that allows you to create objects and intelligent objects up front. The second software tool is EPLAN Fluid. In this same environment, I'm just going to create a new page, and this page is going to be page 5, but it's not going to be a pre-planning page. It's going to be a fluid power schematics page. So here you could do things like pneumatic diagrams, you could do things like hydraulic diagrams, you could do cooling diagrams or lubrication diagrams. So here you would just open up the page. I can insert some symbols. I'm going to see if we have all the libraries needed in this case. So here you've got your pneumatic library, and you can see your fluid power library with your valves. Here you have a unidirectional valve, for example, so you can just simply drop it in there, and you can start laying out your entire pneumatic system. You can either do it symbol by symbol, or you can use a macro to start combining multiple different symbols. In this case, I'm just going to place a valve, and then I can select what type of solenoid I'm going to use for it, and then it's going to adapt the symbology associated with it. So now this is not a wire, it's considered a tube because it's carrying air. But behind that symbol, you can also add your part numbers, and you can store all of your information regarding your bill of materials, as well as your components for the 3D layouts. Then you have your electrical P8, which is your electrical circuitry. So this solenoid needs to be wired up. So if we go to a multi-line page here, schematic multi-line, schematic. Now I could go to the devices that I created. There's my coil, for example. There's my control valve. Where's that coil? It's actually here. Now where is it? Directional control valve. Let me go back to my page here. I'm going to, oh, that's a graphical object. I need to change it to a cross-reference. So now I can view that device in here. And this device, I can now use it in my electrical drawing. So if I went to my electrical page, I went back to my tree, I could simply drag this object in here and use it as this one here, and use it as a coil in my circuit diagram. So the thing is, the platform provides you multiple different software, so you can have pneumatic, hydraulic, electric, and also your 3D panel layout all in one environment. So here, if I create a new layout space, I didn't really change software, I'm just in the same software, but now I can go into my 3D space and design my control cabinet in 3D. So I could insert here an enclosure, select the part number, and drag and drop that component in there very easily. Let me see if this has a 3D. Yep. I'll take this part, for example, and there we go. So depending on the detail, you can have more or less detail, but now you could identify the backplate and you can start dropping the components in. So you already saw pre-planning for your preliminary planning and layout of your system, hydraulics, pneumatics, which is EPLAN fluid. You have EPLAN electric P8 for the controls design. Then you have Pro Panel, Pro Cabinet, and those are the major software. You also have EPLAN harness if you have harness design requirements, and you have the data portal, of course. The data portal provides you with components for your environment. So if I'm here in the data portal, I can navigate the list of manufacturers, whether it's Allen Bradley, whether it's ABB, whether it's Delta or anybody else. Look for parts. So we can go here to Eaton, for example. I can look at the Eaton catalog. And now we've got electrical products. In this case, we got fuse and fuse holders. And here there's a couple of fuses. So here's the device, and I could use this device directly into my schematics, for example. So the data portal is another application that ties into this environment. But as you noticed, I stayed always in the same environment, same menus, same layout, just maybe different navigators, different views, different page types that help you to manage the data for your entire control system in one environment. So if there are no other questions, we can wrap up this meeting or this live webcast.